Satellites have become a cornerstone of our modern world, providing key services from navigation to communication. Unfortunately, this technological progress comes at a price. The more satellites, the greater the damage to our environment and our view of the night sky. But how many is too many?
Since about 2019, human beings have launched more to space than we did in the 60 years of spacefaring nature.
Yeah, it's really this exponential curve, right?
Really good up.
That was Betty Kyoko, Institutional Affairs Officer here at ESO. And what she says sounds worrying. Indeed, the population of satellites has increased dramatically over the last years, reaching a total of 14,000 today. But we ain't seen nothing yet. In the coming years, there are plans to launch a staggering 1.7 million satellites, including some very large ones. And this could cause problems on many levels. One issue is the potentially catastrophic increase of space debris. The more debris, the more likely a collision with another piece of debris, with a satellite or even the International Space Station. Apart from polluting the orbit and ultimately making it unusable, space debris can also re-enter Earth's atmosphere in an uncontrolled way. There have been rare but documented cases of pieces landing in people's backyards. And of course, there is the environmental impact of satellite launches and the burn-up in the atmosphere upon end-of-life re-entry. Working for a ground-based observatory, me and my colleagues at ESO are particularly concerned with a further aspect: satellite light pollution. We already talked about the importance of a dark night sky for astronomy in this video, including the impact of satellites on our view of the cosmos. This is already noticeable with the relatively modest number of small satellites up there now, but so far we're managing. The question is, what will happen if the planned mega constellations and very large and therefore bright satellites are launched into orbit? The two most extreme proposals are those put forward by US companies SpaceX and Reflect Orbital. They are unprecedented in terms of number and brightness of satellites respectively, and are currently undergoing evaluation by the US Federal Communications Commission. Their impact on ground-based astronomy was assessed by a new ESO study. It's the first ever study to not just compute the visibility of individual satellites, but to also quantify how the proposed constellations raise the general brightness level of the sky and affect astronomical observations. The author is Ollie Eno, an astronomer colleague here at ESO. We spoke about why the new plans are so significant, starting with the proposal by SpaceX. SpaceX already has over 10,000 Starlink telecommunication satellites in low Earth orbit, but their future plans include creating space-based data centers to power AI computing.
Really what makes the difference is the number. The Starlink plans to launch up to 40,000 satellites. Currently they have about 10,000. Now the Orbital data center, we're talking about 1 million satellites. So we're talking orders of magnitude more. And so that means that each of them is going to make trails in our images.
These trails appear when satellites illuminated by the sun cross our observations. They block the light from the cosmic objects and reduce the available area of the field of view. Even satellites that are so faint they can't be seen with a naked eye at a dark site leave these trails. With 1 million more satellites up there, dozens of trails would appear in each image taken with our very large telescope, leading to field of view losses of up to 28%. On top of that, hundreds to thousands of these satellites will likely be brighter and visible to the naked eye, competing with the number of visible stars. But with 1 million satellites up there, it's not just their direct light that is an issue.
If you have thousands going one after the other, then that means it also raises the sky background. It's diffuse sky.
Okay.
An analogy is, look at the Milky Way.
While the Milky Way appears as a fuzzy band stretching across the night sky, it's actually composed of billions of individual stars, each too faint to be seen directly. A very large constellation of faint satellites would produce a similar effect. The second satellite constellation considered in Ollie's study was Reflect Orbital's proposal for up to 50,000 mirror satellites, which if launched will be the brightest ever in orbit.
The idea is that they are going to use these mirrors to beam sunlight on the Earth. So if you are in the receiving beam of that satellite, the satellite would look brighter, significantly brighter than the full moon. So to give you an idea, that's a car with full headlights.
Shining right at you.
At a distance of 100 meters.
Oh, wow. And driving, you already know that can really blind you. Yeah.
And that's not only one, but they are planning to send thousands of these. So that would be a complete killer for any observation that needs dark sky.
Now, Reflect Orbital have said that they would never shine the reflected beam at or near observatory sites, but their satellites would still be a problem.
Is that even though most of the light goes in the beam, there will be some light diffused everywhere. And that is still bright enough to be really annoying. So that means that within the beam, the satellite would be brighter than the full moon, but outside of the beam, it would still be like the ISS or like a bright planet. And again, if you have one, that's okay. But if you have thousands of them, it starts to be really an issue.
The issue here is that an object the brightness of, say, Venus can saturate the cameras on some telescopes, leaving not just trails like fainter objects do, but effectively ruining the entire image. With 50,000 such satellites, every single image on a facility like the LSST at the Vera Rubin Observatory in Chile would be destroyed. Because of their brightness, the Reflect Orbital satellites would also produce significant scattered light.
Yeah. Eventually reaches us from all directions. And so if you have one bright star, it contributes, but it's tiny. Now, if you have thousands of them, that means that the whole sky background is going to become brighter and brighter. It could more than double the brightness of the sky. And so that means that for us, if we want to observe something faint and we need, let's say, 1 hour to observe it, if you double the sky background, you need 2 hours. To double the exposure time means that many of the faint things that we are observing, faint galaxies, faint quasars, will just become too faint because you cannot double 10-hour exposures or 20-hour exposures. So that's really a huge effect for us.
Yeah, so we'd really lose science at the end of the day with this kind of...
At the end of the day, if that happens, we lose most of the science that need dark background.
Now that is a scary thought, and obviously something that we here at ESO need to take a stand against. Of course, we're not going to stop all new satellites from going up, but there needs to be a compromise between technological advancement and what we can live with in terms of ground-based astronomical observations.
Question has come over and over, how many satellites is too many for astronomy? And we've had to say it's still work in progress, we still quantify. So Ollie's paper answers that question for us. It's critical, really, because it gives the language of legislation. A lot of times when you want countries or international bodies to legislate on an issue, the technical support cannot be understated.
A good measure for the losses of observations we're willing to accept due to satellites is how much we're currently losing due to technical issues like equipment failures. Technical losses account for 2 to 3% of all observing time, an agreed trade-off between the cost of the failure and the cost of preventing it.
So that means that it would be really good if the losses that we have because of the satellites is within that budget, let's say of the order of 2 to 3%. And then running the number that corresponds to 100,000 satellites with magnitude fainter than 7. Magnitude 7, that's the brightness of the faintest star that you can see with your eyes from a perfectly dark place, perfectly dark sky.
So the 1.7 million satellites currently proposed for launch go far beyond the limit of what astronomy can withstand. In Ollie's limit, there is a balance between number and brightness. If satellites are much brighter than magnitude 7, there must be much fewer. We're talking tens rather than tens of thousands. On the other hand, for mega constellations such as the orbital data centers planned by SpaceX, satellites must be much fainter. And while reducing the brightness of satellites is a challenge, it is feasible.
Magnitude 7 is really a hard number for the satellite industry.
And have you communicated with them about this?
Yeah.
Are there any efforts to reduce the brightness?
Very good interaction with the satellite engineers. Well, nerds talking to nerds. Some of these companies have managed to make the satellite much fainter by different coating, by different way to have the orientation of the satellite, of the solar panel. So all this helps a lot.
The question is, how do we apply the findings of Ollie's study in practice and drive legislation to protect the night sky?
So unfortunately, human beings and technology tend to move faster than laws oftentimes, right? And it's just one thing that we have to contend with. So a lot of the legislation we have, both internationally and at national levels, was initially crafted for significantly less volume. So the Outer Space Treaty, for example, is one of the oldest treaties that govern space. It is also the foremost recognized international instruments on how different countries should engage with space. One of its core values is that countries and not companies are responsible for everything that's deployed to space from within their jurisdiction. But what does that look like in an age where private companies can deploy very high volumes to space, and where outside of perhaps the host capability and helping them navigate the international landscape, countries are perhaps even a step behind?
Regulating the use of space is an ongoing battle that's being fought on many levels. Regarding the protection of the night sky from satellites, ESO has joined forces with a range of international partners, including joining the International Astronomical Union Centre for the Protection of Dark and Quiet Skies, and being an observer on the United Nations body that discusses outer space regulation.
It must be said that everything that's happening globally and geopolitically still affects the pace at which these things move. And I say this because I know we're talking at a time where global faith in international systems is maybe at an all-time low. However, there is a lot of goodwill to figure out space issues.
If the SpaceX and Reflect orbital constellations are launched as planned, this would be a major blow to professional ground-based astronomy. In addition, the brighter satellites would dramatically change the view of the night sky for everybody. From darker sites, you would see hundreds to thousands of new bright points, while from light-polluted cities such as Munich, where I live, these will be the only stars that you can see. But there is hope, and I will let Betty have the last word on this.
Right, so at a technical level, we have collaboration between our scientists and astronomers and engineers in the space companies. At a lawmaking process, we're starting to see an uptake from national governments and international organizations, and an appreciation that it's a problem that needs solving, that people need to pay attention to it. So although it's slow, the collaboration and positive reception gives me hope that there's still a chance that something positive could come out of it.